Alright, geometry, now that we are familiar with SOHCAHTOA, we're going to, and the whole right triangle trigonometry, we're going to take that and apply it probably in a way that you wouldn't really expect, but we're going to be doing something pretty specific here, finding the area of regular polygons. And regular doesn't mean like normal or something. It means everything's the same. It's kind of like everything is congruent. You know, all the sides, the edges all the way around are all the same. All the angles all the way around are all the same. All the central angle, everything's the same. So, let's do it now. Okay, so we're going to apply this. Let's look at this first one. So I'm going to cheat here a little bit. You guys can use a straight edge on your paper. I'm going to use a straight edge as well. And so this is what I'm going to do. I'm going to draw a straight line from corner to corner, and really what I'm doing, well, that's a white line. Let's take that back. Let's make it a black line. There we go. Alright, now we got what we want. I'm going to draw these lines in here, and you can't always go from corner to corner because sometimes you have an odd number of sides, like in the next one, which we will see. But what I just did is I took this regular polygon that had all these sides that were equal, and I split it up into 6 equal triangles, which means all these angles around the middle are equal. And then here's what I see. So I now see one triangle, like this. I'm going to do this one that's on the bottom here that's got 7. And this angle here is this full circle split up into how many equal parts? Let's see, we got 1, 2, 3, 4, 5, 6. There's 6 equal parts. So that means that it's the whole circle, which is 360, divided by 6, and that's going to be 60. So that means up here in the top, this would be 60. And I could find more information, but here's all I really need. I have the 7. Now I'm going to split this again into halves. So I'm just going to take half of it right here, which would mean this is 3.5. And then this is 30. And you're probably asking, okay, why? Well, with trigonometry, if I make a right triangle, I can find missing side lengths. And to find the area of just one of these triangles, I need a base, but I also need a height that kind of goes right here in the middle. So right now I'm about to find that height using that trigonometry. Once I know those things, then I can find the area of one triangle, because the area of one is going to be half base times height, which is 7 times whatever the height is. Excuse me. And then the area of 6 triangles is just 6 times whatever that was. Okay, well, let's see what we get then. So this height right here, I need to do some trigonometry. So let's start. We got 3.5 on the opposite side. 30 is my angle, and I'm trying to find the adjacent. So I got opposite and adjacent, which means I'm doing TOA, tangent. So tangent 30 equals the opposite, which is 3.5, over the adjacent. We'll call it A. So I have a table. Where is it at? It's not this one. It's right here. Here we go. Trig calculations. And tangent of 30 could be found in this table. See, sine, cosine, tangent goes across the top. I'm looking for 30, which is the last one down here. That was 0.58. Now, we are going to get a lot of decimal approximations because, for example, you might notice the special qualities of that triangle and how we could find exact values, but I'm just trying to get some basic calculations done. So this is 0.58 equals 3.5 divided by A. No big deal. But now you do some algebra, you multiply both sides by A, divide both sides by 0.58. 0.58. I'm running into this other shape over there, times A times A. We got A's cancel 58s, simplify, all of it simplifies, and then we got A equals 3.5 divided by 0.58. Well, let's see what that is. I have a calculator. Mine's pretty super duper here, but yours would work just the same. So, what is it? 3.5. 3.5 divided by 0.58 and 6.03. So this is equal to 6.03. I'm just approximating here. So I'm going to call this right here 6.03. Fill that in for my height, because the area of one triangle is half base times height. So I'm going to take that number times 7, then divide it by 2. So I'm going to do that times 7, and then divide it by 2. And that gives me 21.12. And then I have 6 of them, so why don't I do that right now too? So I'm going to take that answer and then multiply by 6, and boom, there it is, 126.7. So this was like 21.12 or something like that. And so then that equals 126.7. Pretty sure it's 7. Boom! There's the answer. So we found the area of one triangle by finding the height using trigonometry, and then we multiplied that answer by 6. Alright. Piece of cake, right? Okay, so I've lost a bunch of workspace here. I'm going to try and regain some back. First, I know it's going to be kind of hard because I wrote all over it, but I need to count the number of sides here. And I don't know if you noticed, but this one, it looks like you can't go straight across, because if I were to go from corner to corner, I'm not going to cross through that center point. So instead, this time, I got to go from the center point out to each vertex. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think there's 11 pieces, but let's mark it just to be sure. It's not bad to write down what you're thinking. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 that make this full circle. Now we're going to go through the same process. So first we split into equal triangles. That's a triangle there, by the way. And then we calculate height of one triangle using trig, which is the SOHCAHTOA stuff. And then 3, we do the area of one, and then one triangle. And then we do the area of all triangles, which is just multiplying it by however many triangles there are. So this has 11 triangles, so I got to split it into triangles. We got one triangle here. Looks kind of like this. The base here is 2. And if I need to find out just half of it, because remember, I want to take half of it so I could find the height using like that right triangle shape there, like this. But I need to know this angle. Well, I got to take 360, divide it into 11 pieces to get this angle for the one full triangle, and then I got to split that in half to do the trigonometry stuff. So I'm not even going to chance it here. Take my calculator, 360 divided by 11, because there's 11 triangles. We got 32.72. Then we divide that by 2, and we get 16.3. Let's go ahead and round it off, because we only have angles in the chart and round it off to the 1. So 16 would be the angle right there, 16. And we know that the whole thing here is 2, so this half is just 1. And then I got to find the height. We'll call it the adjacent again. So this, if I'm looking at it, would be, okay, so how do we calculate this? We got tangent again. Tangent of 16 equals opposite over adjacent, which is 1 over the A. And now if we kind of do some algebra again, you're going to find out that A equals 1 divided by tangent of 16. Okay, so I need to look up what's tangent of 16. Tangent of 16 is 0.29. Okay, it's 0.29. So I'm going to go to my calculator, and I'm going to do 1 divided by 0.29, and I get 3.44 or 3.45, either way. How about just 3.4? So A equals 3.4. That's 3.4. Now, that's my height there. Okay, so to find the area of one triangle, the area of this triangle is half base, which is 2, times the height, which is 3.4, which magically in the numbers of calculation, 1/2 of 2 is 1, and 1 times 3.4 is 3.4. So then I just got to take that number and multiply it by 11, which I still have that number. Why by 11? Why, you might ask? Because the area of the whole shape, there's 11 triangles. So it's going to be 3.4 times 11. So we'll probably be in the 30s somewhere. So we're going to take that number. Hey, look, it's still there. So I'm just going to do times 11. Magically, we get 37.93. So this equals 37.93. Awesome. Remember, I'm not going to slow down, but if you need to slow me down to write things down or watch it again, you do so. You have control of the pace because you got pause, play, rewind, etc. All right, let's do another one. Notice this one, again, it's got an odd number of sides. How can I tell that? Because when I try to go from one side to the other, it doesn't cut even or equally through the middle. So I'm going to take that back. I'm just going to mark where I think about the middle point is. This is totally a guess, guys. These are approximations just for being able to visualize stuff. Now I'm going to draw straight lines to each corner to split this up into triangles that are equal. Again, just to visualize. You don't have to do this, but it sure does help to see things. Okay, so we got this. Remember, we take 360 divided by how many sides there are. So we got 1, 2, 3, 4, 5, 6, 7. So there's 7 pieces there. Okay, so I'm going to do 360 divided by 7 to do one triangle. And we're looking at one triangle. It's got 8 down here. We've got to figure out how much this is. And then we're going to split that in half. So we get a right triangle. This will be 4, and then we'll have that angle split in half. Okay, so we start with 360 divided by 7, which is 51.42. And then we're going to divide that by 2, and that gives us 25.7. Let's round off to 26. So this right here is going to be 26. And we're going to have that same setup, you know. Tangent of 26 degrees equals the opposite, which is 4 in this case, over the adjacent, which we're calling A, again. We do some fancy math. We multiply by A on each side, divide by tangent 26 on each side, and what do you know? We come up with the same pattern again. It's like over and over and over again. A equals 4, that half base, over tangent of that half angle, which in this case is 26. And well, let's see let's do that. Tangent 26 is 0.49. Okay, so then I go to my calculator and I do 4 divided by 0.49, should be about double it. 8.16. 8.16 is what we're looking at. So this is about 8.16. This is 8.16 for that height. So now the area of this triangle right here is going to be 1/2 the base, which is 8, times 8.16. Well, let's see what that is. So we're going to do that times 8 and then divided by 2 because we're taking half of it. 32.65. So this is 32.65. And how many triangles are there? Well, there's 7. So the area of 7 of those is 7 times 32.65. And let's see what we would get. So we're going to take that times 7. Times 7 equals 228.57. 228.57. Booyah! We're getting better at this. A lot better. Alright, let's do it again. Alright, so we got a center point probably about here. And this time, I think there's an even number of sides, because check this out. If I were to go straight through, I pass right through that middle. So I'm just going to do that. It's less lines for me to draw. There we go. We just got to make sure that we're going right through that middle every time. You don't want to split it up incorrectly. Okay, we got lots of sides on this one. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 sides, or 12 triangles, I guess, is what we're really caring about. So we got 12 triangles, each with a base 3, but with a height unknown. So let's figure that out. So we're going to take 360 this time and divide it by 12. That should go in evenly. And it gives us 30. Okay, so this up here, this is 30 degrees, but we're going to take just half of that so we can figure out the height using the SOHCAHTOA relationship. So half of that would be 15. That's easy enough to just do in my head. And half of the 3 is 1.5. Okay, so here is our calculation. Tangent, ready? Tangent of 15, in this case, is equal to the opposite, which is 1.5, divided by the adjacent, which we keep calling A. And then we do the math, and we get A equals 1.5 divided by tangent of 15. Well, what's tangent of 15? Let's double check that. Tangent of 15 is 0.27. Okay, 0.27, so that's 1.5 divided by 0.27. And so 1.5 divided by 0.27. That gives us 5.555555555. So that's 5.5, let's call it. And so this right here is 5.5. And the area of just one triangle is, again, 1/2. Then the base is 3 times 5.5. So we're going to multiply that number we just got times 3, then divided it by 2 because the half in there. And for one triangle we get 8.3333, so 8.3 about. Then how many triangles were there? There's 12 of them. So we're going to take that answer and do times 12, and we get 100. Now you probably have a slight underestimation because I didn't round off these numbers until, only in the trig chart table did I round them off. But it should be about 100. So the area of 12 of them equals 12 times 8.3-ish, which is about 100. That's awesome. 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 How many more of these do we got? Quite a bit, I bet. There's probably about 10 of them. So we're probably about halfway. Let's see. That many? Yep, we got 6 more. Thankfully, number 75 and 76, pretty much the same thing. So we can repeat a lot of stuff. So let's start with this. We're going to mark our little center point here. And now we're going to draw lines to each corner just so we can visually see what's happening. Remember, all these triangles are equal because this shape is very symmetrical here. So we got 360 divided into 5 pieces. 1, 2, 3, 4, 5. So 360 divided by 5. I actually know what that's going to be, I think. Let me double check. Yeah, it is. It's going to be 72. But if you need, go ahead, because we'd have 360 divided by 5. 72. But then we got to divide that in half because of the we're taking just half of it right here. So that means this piece would be half that, which is 36. And half of 5 would be 2.5. We got 2.5 in each half. So I'm marking most of this on the picture. Let's see if we can figure it out from here. That means that we'll call this A. Tangent 36, tangent of this 36 is opposite, which is 2.5 over the A piece. So that's 2.5 over A. Then we do the algebra, multiply by A, divided by tangent 36. And here we come. Simplify the A, simplify tangent 36. And, well, what is tangent 36? Okay, tangent 36, that's going to be in the second set of numbers here, would be 0.73. Remember, tangent is the third one. We got sine, cosine, and tangent here. So 0.73. 0.73. So A equals 2.5 divided by 0.73. Let's see what that would become. 2.5 divided by 7.3, and we get 0.3424, so this is about 0.34. Then the area of one triangle. The area of one triangle is, remember, half base times height. Well, the base was 5 of each of these triangles. And the height is 0.34. Is that right? No. No. Something. What's going on here? What did I... Ah! It's 3.4. Watch this. So if I did 2.5 divided by 0.73, I did 7.3. Whoops. Should have been 3.4. So adjust this number. And that really didn't make sense. I mean, it's longer than 2.5. So 3.4. Alright, so then we put a 3.4 here. Let's see what the area of one triangle is. We take that number, and we do times 5, the base, divided in half because it's a triangle, and we get 8.56. And how many are there? There's 5 of them. 5 of them here. So we got to multiply that answer by 5. Times 5. 42.8. So the area of 5 triangles is going to be 42.8. Approximately, of course. Okay, so when we get to this next one, what is really the main difference? You know, we still have a pentagon here, which is a 5-sided figure. And so we're going to split it up into the 5 triangles. But a lot of the angle calculation is going to be the same because we still have 5 triangles. Which means that one of these triangles is 72. And half of, whoops, let's draw that a little more straight. There we go. Okay. And half of that is 36. And again, this is just going to be 3.5 instead of 2.5. And tangent of 36 is going to be the same. So pretty much I can take this calculation and translate it over. Because remember, we're just taking that half base divided by tangent 36. So A in this case is going to be 3.5 divided by 0.73. Let's make sure we do the 0.73 correctly this time. So we'll have 3.5 divided by 0.73, and that gives us 4.79. 4.79. We're going to take that answer. Remember, the area of one triangle is half the base, which in this case is 7. Times the height, which we just found out to be 4.79. So we're going to take that times 7 and divide it by 2 times 7 divided by 2. We get 16.78. So that's 16.78. That's one of them, but then we got to multiply that by 5, just like we did before, times 5, and we get 83.9. So the area of 5 of them is 83.9. Awesome. Those two went pretty fast. Let's kind of wrap it up here. We got, just a few more. Ooh, come on, guys. 78. Okay, you could do it the way we've been doing it, but just think, use your head a little bit. Even if you were to split this up into 4 equal triangles, it's a freaking square. Look at this. 4 times 4 is 16. The area equals 16. Okay, don't overthink it. There you go. All right. Here we go. Let's take a look at this one. This means we can drag through the center. Look at that. We got an octagon like a stop sign. So it's going to be really similar to the ones we've done before, but this has 1, 2, 3, 4, 5, 6, 7, 8 sides for 8 triangles, which means we're going to take 360 divided by 8. Let's see what we come up with. 360 divided by 8 gives me 45, but then I got to divide that in half, divided by 2, and that's going to give me 22.5. Okay, so that's 45 for, just the one triangle. That's 45. But we're really interested in that half triangle, which is 22.5 degrees. And half of this piece here is going to be 1. Okay, so let's set up our little relationship. That means that tangent of 22.5 is going to be the opposite side 1 over the height again, A. Multiply by A, divide by tangent 22.5 divided by tangent 22.5. So let's see what that would be. And then tangent 22.5. Oh, we got to round that off. Well, look at this. 22 is 0.40. 23 is 0.42. So let's go right in the middle. 0.41. So we're going to do 1 divided by 0.41. That gives me 2.439 or 2.44. So A equals 2.44. Alright, so the area now, the area of one triangle, the area of this one triangle is going to be half the base times the height. The height, or the base is 2. The height is 2.44. So we're going to take that times 2, then divide it by 2. So wait a second. That's just 2.44. So that's 2.44. And then how many of them are there? There's 8 of them. So the area of 8 of them is going to be equal to 8 times that. So 8 times whatever we just got, the answer that we just got, 19.5. Check. Done. There we go. Alright, I've done most of these for you guys, and I really think that some of these are just repetitive. It's kind of getting to that point where it is very repetitive here. Like this one has the 11 sides and this piece, so you can check that one out. This one has 10 sides, it looks like, and you could probably figure that one out as well. So we're going to end it there. You guys can finish the last two end of Unit 7, Part 2 of 4. Remember, Parts 3 and 4 are coming. Part 1, I'm actually going to do last because it's the easiest stuff. But we'll see you in the next one, which is solving with multiple triangles.